Hi guys, in this video we are solving a new problem, and in this problem we are given two integer arrays, nums1 and nums2, and they're both sorted in non-descending order or in ascending order. And we are also given m and n integers, which represents the number of elements in nums1 and nums2. And what we are expected is that we merge these nums1 and nums2 array such that the final array is also sorted in non-descending order or in ascending order. And a tricky part here in this question is that we want the final array to be in nums1 itself. You can see in example 1 that might make it a little more clear. You can see nums1 has about 6 elements and m is 3, which means that only the first 3 elements are the elements in nums1. Rest of the elements are all 0 and they should be ignored initially. Nums2 have 3 elements with n equals to 3. That makes sense. And the length of nums1 is m plus n. Basically, we want the nums1 array has size or length such that the final output, the final array, could fit inside the nums1 in itself. So we want to change nums1 in place, and we don't want the function to return anything. As you can see, the output is a single array and it is sorted in ascending order. So that's the problem statement. And it's obvious that in this problem we'll be using merge sort, because merge sort is something that you use to merge two sorted array. But the problem again is that we have to do it in place in nums1 array in itself. I've actually written the solution, so I'll be copying the solution here first. The solution looks something like this. In the solution, first we find the length of nums1, which is simply m plus n. So we could do m plus n or find the length of nums1 in itself. Maybe m plus n is better here. And we have a loop. Now this loop is not a loop that compares elements of nums1 and nums2, just like in merge sort. And the condition to continue looping is simply when m is greater than 0 and n is greater than 0. That's right. And inside the loop we have if-else statement. In the if statement, what we are checking is that this is basically merge sort in practice. If the element in nums1, and now if you look at the index we're using, it is m minus 1, which means that we're here looking at the last valid element of nums1. So if this was the example, if example 1 was the case, then this particular nums1 at position or index m minus 1, it represents this particular 3. So we're comparing this 3 with the last element of nums2, which is 6. The reason we are doing from the end rather than from the beginning, rather than from the starting position, is because we are doing a reversed merge sort in some sort. Like we are doing from the backwards. The reason we are doing from the backwards is because we are finding the largest number and then assigning it to the end of the nums1, such that we can start filling up the nums1 without any issue, because we need to do it in place anyway. So yeah, we're comparing the last elements of these two arrays, and if nums1 element is greater, then we know that this particular 3 needs to be placed at the end. But we know that 3 is smaller than 6, so this if statement is not executed, rather else statement is executed. And in else statement, what we are doing here is that we are assigning the last element of nums2, which is 6, at the end of nums1. So you can see k is another pointer. We made a new pointer which points to the last element of the nums1. So we are assigning 6 to the last element of nums1. And also we want to decrement the, or basically shift the end pointer. Basically we want the now pointer, our end pointer, to be pointing at 5, just like in the merge sort. In the second iteration, also I forgot about the k. Now the k should stop pointing at the last element of nums1, but the second last element, and that's why this is this statement we want to run. In the second iteration, we can compare this 5 with 3, and 5 is greater, so we assign 5 to the second last element of nums1. And again, after that, we compare 2 with 3. In this time, 3 is greater than 2, and therefore 3 is assigned in the third last position. This loop continues as long as m and both n is greater than 0. If either one of them either one of those pointer decreases to 0, then this loop ends there. And after the loop ends, I have a small code which checks if n is greater than 0 or not. If n is greater than 0, it means that there are some elements in nums2 array that are not properly assigned back to nums1. In that case, we have to assign them back to nums1 by basically iterating through them. So here I have a loop basically that runs from whatever value n is all the way to 0 in reversed order, and in the loop I'm simply assigning the nums2 elements that are left out back to nums1 array. And if you've noticed that I'm not checking if m is greater than 0 or not. If m is greater than 0, it means that there are some elements in nums1 that are not assigned to nums1 array, but we don't have to assign it because nums1 is already assigned with the elements of nums1, so basically we don't have to copy them manually, just like for nums2. So we don't have to do that. So yeah, I can run this code now. It should pass all the test cases. Right, it does. And if I submit it, it does complete in 0 milliseconds. That's great.